Our lesson today is about valence electrons, electron dot diagram or Lewis dot structure, and how we can make use of the periodic table in order to determine valence electrons and electron dot diagram. But first, let us review again our atomic model. We learned in our past lesson that here in the center of the atom is the nucleus. It contains the protons and neutrons. Now, then the electrons are outside the nucleus on orbit or energy level. We will call it at energy level. And this one, closest to the nucleus, is the first energy level, followed by the second energy level, and the third energy level, and then we can still have the fourth energy level here, and the fifth, okay? But we will only limit to the third energy level to simplify our objective, how to determine the valence electrons, okay? Now, this concept, so that we could easily understand it, we could relate it with a typical situation in the mall, right? We can relate it with the mall, right? If this is the mall, the nucleus is the mall, then the mall has parking space. So we can relate it with the parking space in the mall that immediately nearest the mall is the first level that can hold only 2 cars, right? And then after that, if it is already filled up, then it will go to the next level that can hold 8. And when it is filled up, it will proceed to the next level, and so on and so forth. Okay? So, to relate the concept with the periodic table, we will study only these groups of periodic table. We will not include this group of elements. So that is why I have here in the diagram, these are the group B elements, and these are the group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. So let us have the group 1A element. Okay, so the group 1A elements, we have in group 1A, okay, in group 1A, of course, we have the hydrogen, right? Hydrogen and lithium and sodium. So we have it. And the atomic number of hydrogen is 1. So that means the number of proton is 1, and hydrogen being a neutral atom, the number of electron is also 1, right? So that we will be, and it will stay, if this is the nucleus, the protons, it will stay here. That 1 electron, right? That 1 electron. Okay. What about beryllium? Okay, look at look at lithium. The lithium next to hydrogen has 3 atomic number. Okay, so that means 3 protons again and 3 electrons. So these are the protons, the 3, and the 3 electrons. The first energy level again can hold a maximum of 2. So the other electron will go to the next energy level, the second energy level. Okay, so the sodium 11 atomic number under lithium has 11 atomic number, therefore 11 protons again. Okay, and that 11 electrons, first again, the first 2 will occupy the first energy level. So 11 minus 2, there are still 9 electrons, right? But the second energy level can hold only 8. So this is 1, 2, 3, 4, okay, 5, 6, 7, 8. So 8. And we still need 1, right? Because 2 plus 8, 10. So another 1 electron will be here. Okay? So what do you notice? What do you notice? We notice that the group 1A, I'm telling you, including the rest of the elements in group 1A, has 1 valence electron. So therefore, we can say that all elements in group 1A has 1 valence electron because we define valence electron as the electrons at the highest energy level or the farthest from the nucleus. Okay, so that means 1 valence electron. So it has 1 valence electron, all of the elements in group 1A. And we describe the Lewis dot structure as the symbol of the element with the dots. And that number of dots is exactly equal to the number of valence electrons. So to illustrate that, we can illustrate the group 1A. Let's have lithium representing the group 1A. This is lithium, right? With 1 dot. And that dot is the number of valence electron. Okay? So, let's proceed with the group 2A. So, the group 2A in the periodic table, we have in the periodic table, the group 2A are beryllium, magnesium, calcium, strontium, but we will only consider beryllium. Okay, beryllium. So this is beryllium, led by beryllium, the group 2A. Now, beryllium in the periodic table has 4 atomic number, therefore 4 protons, and it is a neutral atom, therefore there are 4 electrons. So those 4 electrons are here. 1, 2, okay, 3, and 4. So we say beryllium has 2 valence electrons, right? And so let us go back again with the definition of the electron dot diagram. It is the symbol of the element. So what is the symbol of beryllium? The symbol of beryllium is Be, and then the dots represents the number of valence electron. So that is why we will have 2 dots, right? Similarly for magnesium, magnesium has 12 atomic number located under beryllium. Similarly, the number of course, the protons again, the 12 protons, and the 12 electrons, because it is a neutral atom. Therefore, the first 2 electrons are on the first energy level. Of course, the rest are on the second energy level, the other 8, right? So, 1, 2, okay, 3, 4, okay, 3, 4, and then we have 5, 6, 7, and 8. So 2 plus 8, 10. So there are 2 more, right? So the other 2 valence electrons are in here. So we have 2 valence electrons. So they are the same, right? They both have the same 2 valence electrons. So that is why we can write the Lewis dot structure for magnesium with 2 dots. Okay? So this group 2A, we can represent it with the electron dot of beryllium, electron dot diagram. Okay. With 2 dots. Okay. So, we go to group 3A. So, the group 3A let's go to group 3A. In the periodic table, the group 3A is led by boron, aluminum, and down. But we will only consider boron and aluminum. Okay? So let's have boron and aluminum. So, in the periodic table, so I always emphasize periodic table because for you to realize that periodic table is a very good reference. So, boron is 5. Therefore, 5 protons. And how many neutron? I mean, how many electrons? Of course, 5 because it's a neutral atom. So, the first 2 electrons, okay? So, again, the first 2 electrons go to the first energy level. And then the remaining 3 are on the second energy level. 1, 2, and 3. Okay? Now, what about, so that means that boron, the electron dot diagram is the symbol of boron. So we have boron with 3 valence electrons. Okay. Now, what about aluminum? Aluminum has 13 protons. Okay. So, it has 13 protons, 13 atomic number, 13 protons, neutral atom, therefore, 13 electrons. So, again, the protons, the 13 protons are here. And on the first energy level, there are 2 electrons, followed by the second energy level with a maximum again of 8. So, 2, 3, 4, okay, 5, 6, 7, and 8. And we have 13. 2 plus 8, 10. So, 3 more, right? So, the 3 more electrons will go to the next third energy level. And so, that means it has 3 valence electrons. And so, the electron dot diagram for aluminum is with 3 dots. Remember, the dots is equal to the valence electron. Okay? So, we can represent now that group 3A with boron. Boron with 3 dots. Okay? And then we have the group 4. The group 4A. So, let's make this quick. So, the group 4A elements led by carbon. And we will have only carbon and silicon to represent. Okay? So, carbon has 6 atomic number, therefore 6 protons. Carbon is neutral, therefore 6 electrons. So, we will have the 6 protons here. Okay, in the nucleus. And the 6 electrons again here. First 2 on the first energy level. And the rest of the 4 on the next energy level. So, 1, 2, 3, 4. Okay? So, as you can see, we have 4 valence electrons for carbon. Thus, our carbon electron dot diagram is this. 1, 2, 3, 4. Okay, represented by the valence electrons are the dots. Similarly with silicon, 14 atomic number, therefore 14 protons. Therefore, again, the 14 protons are here. And the 14 electrons, the 2 electrons on the first energy level. And then on the second energy level, again, are the 8. So, 2, 3, 4, 5, 6, 7, and 8. So, 10. 4 more. The 4 valence electrons will proceed to the next energy level. So 1, 2, 3, and 4. So look at the electron dot diagram of silicon. Silicon with the 4 valence electron. 1, 2, 3, and 4. They have the same number, right? So, therefore, we will represent this group 4 with carbon. 1, 2, 3, and 4. Okay? I think you are recognizing a trend at this point in time. Am I right? So, let us proceed now to the group 5A. So, the group 5A in the periodic table is led by nitrogen, phosphorus, down. So, we will only consider nitrogen and phosphorus, okay? So, look at nitrogen. 7 atomic number, therefore 7 protons, neutral atom, 7 electrons. So, again, we will have it here. So, we have the protons again on the nucleus. And then we'll have the 7 electrons again on the first energy level, the 2. And the remaining 5 goes to the second energy level. So 1, 2, 3, 4, 5. Okay? So, that means there are 5 valence electrons, group 5A, and the electron dot structure for nitrogen is this 1, okay, 2, 3, 4, 5. See, 5. What about phosphorus? The phosphorus has 15 atomic number. So, 15 atomic number, therefore, it is equal to 15 protons, and phosphorus atom is neutral, therefore, it contains 15 electrons as well. So, to represent, again, these are the protons, and then we'll have the first 2 electrons again on the first energy level. The second energy level contains the 8, 1, 2, 3, 4, okay, and then 5, 6, okay, 7, and 8. Okay, so 2 plus 8, 10, 5 more. So where will it go? To the second energy level. 1, 2, 3, 4, then 5. So, similarly, both phosphorus and nitrogen have 5 valence electrons. Therefore, we can represent the electron dot structure of phosphorus like this. Okay? 1, 2, 3, 4, 5. So, what do you notice? The elements in group 5A have 5 valence electrons. And so, let us represent that with nitrogen with 5 valence electron. 1, okay, with 5 valence electron. Now, group 6A, we're almost done. Group 6A in the periodic table is led by oxygen with 8 atomic number, then down is sulfur, selenium, but we will only focus on oxygen and sulfur. So look at oxygen. Oxygen has 8 protons and therefore 8 electrons. Neutral atom, therefore 8 electrons. Similarly, the first 2 electrons, so here is the protons, the first 2 electrons here. Okay, and there are 8, so the remaining 6 will be here. 1, 2, 3, 4, 5, 6. So 6 plus 2, 8. So that means that the electron dot diagram of oxygen has 6 valence electrons. 1, 2, 3, 4, 5, and 6. Okay? 6. Similarly with sulfur, there are 16 atomic number, therefore 16 protons. And if this is the proton once again, then we'll have the 16 electrons again. The first energy level can only hold 2 electrons. The second can hold 8. Okay, so 2, 3, 4, 5, 6, 7, and 8. So 2 plus 8, 10. 6 more, right? So the 6 electrons will occupy the next energy level. 1, 2, 3, 4, 5, 6. 16. And how many valence electron? 1, 2, 3, 4, 5, 6. Like oxygen, 6, right? So therefore, we write the electron dot structure of sulfur 1, 2, 3, 4, 5, 6. 2, 4, 6. So we will represent the group 6A with oxygen. So here is oxygen with 6 valence electrons. Okay? Now, we proceed now to group 7A. Group 7A, on the periodic table, on top is fluorine, followed by chlorine, bromine, iodine, and astatine. But we will only illustrate using fluorine and chlorine. So look, the atomic number of fluorine is 9. Therefore, the proton is 9. Fluorine is a neutral atom. Therefore, the electron is also 9. Okay? So, let us illustrate it also. So, this is the protons, 9 protons, and we'll have the 9 electrons. Again, the 2 electrons on the first energy level, 9 minus 2, therefore the 7 electrons are on the second energy level. 1, 2, 3, 4, 5, 6, 7, okay, 2 plus 7, 9. So that means we can represent fluorine with 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So 7 valence electron. Okay, similarly with chlorine, 17 protons and 17 electrons. Therefore, you have, because it is a neutral, here again is the 17 protons and the 17 electrons. Look, the first 2 electron again on the first energy level. So 17 minus 2, okay, is 15, right? Therefore, we have the second energy level can hold only 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8, 10. So 2 plus 8, 10. So 7 more, right? So where will it go? To the next energy level. So we will draw another energy level or the third energy level. So 7, right? So those 7 electrons, 1, 2. Of course, 3 here, 4, 5, 6, 7. So similarly with fluorine, chlorine will now have this kind of Lewis dot structure. Okay. Okay, like this. So you have chlorine with 7 dots. 1, 2, 3, 4, 5, 6, 7. Okay, so fluorine and chlorine have 7 valence electrons. So we will represent group 7A with fluorine having 7 valence electron. Okay. Now let's go now to the group 8A. So the group 8A elements is led by helium, neon, argon, but we will only consider helium and neon, and of course argon. So here, helium has 2 atomic number, therefore 2 protons, 2 electrons because it is neutral. So this is the protons, and we have only 2 electrons, right? 2 electrons. So it is an atom with complete shell, right? Now let's go to neon. Neon atomic number is 10. Therefore, 10 protons. The neon is neutral atom, therefore 10 electrons. So let us have it again. This is the protons, the 10, and the 10 electrons. First 2 electrons on the first energy level, and then the next, how many? 8. 1, 2, 3, 4, 5, 6, 7, 8. So we represent neon with 8 valence electron. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And we will represent the group 8A with neon with 8 valence electrons. Like argon, 18 atomic number, therefore 18 protons. So you have 18 protons, and of course, the first 2 electrons, and the 8 on the second energy level. 4, 6, 7, 8. Yeah. Now, what about the other 8? Of course, on the third energy level. 1, 2, 3, 4, 5, 6, 7, 8. So both of them have 8 valence electron, and so we represent the argon electron dot symbol with similar with neon, 8 valence electron. Okay? So that's it. Therefore, we say there is a pattern, right? You observe what is the pattern on each group of elements in the periodic table. And to maximize your learning on the importance of periodic table, this is, we call the period number, right? So this is period number 1 in the periodic table. This period number has only 2 elements. What are they? They are the hydrogen and the helium, right? Okay, so next is period 2. And what are the elements in period 2? From lithium to neon. Then we have period 3, period 4, period 5, 6, and 7. So that means these elements in this corresponding period, okay, to maximize the use of periodic table, I am telling you this is the highest energy level. So you can maximize the use of periodic table. So the period number represents the highest energy level. Okay? So I hope you realize that we can use the periodic table by determining the valence electrons, which are very powerful, the most powerful electrons, because they are the ones involved in chemical bonding, in chemical reaction. And it is nice to know by looking at the periodic table that we can easily determine. So, if it is under group 1A, we know it has one valence electron. So, again, the valence electrons are the electrons in the highest energy level, and the electron dot diagram or Lewis dot structure are the symbol of the elements with the dots representing the valence electron.